So to begin working with the ASA, it's going to be a bit different from a router. With a router, when we put IP addresses on an interface and perhaps do a no shut, if the link is up, layer 2, and the other side's configured correctly, layer 3, we should be able to go ahead and ping it. With the ASA, it's not quite so easy. To get an interface to pass traffic, we've got to do 2 additional steps. One, which is name it. Think inside, outside, DMZ, extranet, things like this. They're pretty straightforward. Besides naming it, you've also got to do security levels, and security levels are pretty easy to understand, but it's something that can get you in a bit of trouble in the more complex situations. A couple slides on this. We'll cover the complex scenarios towards the end, and I think everybody should have a good grip on it. So go ahead and taking a look at the interface security levels. Like I said, every interface in order to pass traffic needs a name, security level, IP address, and of course do a no shut. Now, where that security level comes in is pretty critical. In the old days, we called it the adaptive security algorithm. And it's really truly what made a firewall a bit different from looking at a router. Let's just bring up a whiteboard here. When I take a look at my firewall, I'm going to, let's do a quick circle here. All right. And let's say that on one side of it, I've got the outside. This is what's going to plug into the intranet, which I do not trust. And I give a security level of 0. On the other side, I've got all my users. I've got my accountants. I've got my executives. I don't want any of this stuff breached. So I come over here and I say this is going to be the inside, and it's going to have a security level of 100. Now you have 101 different security levels because we start at 0, 0 being the lowest, 100 being the highest. One way I kind of thought about this when I first started learning was looking at it and kind of thinking of it as elevation. And the reason that I thought of it as elevation is, if you dump water on the ground at 100 feet, it could roll down to 0. But to get water from 0 feet, or sea level, up to a mountain, we're going to need a pump, we're going to need some plumbing. In the old days, they called it conduits. Today, we would just use simply an access control list. So let's take our color here and just move towards green. Green is going to show you what will work naturally. To go from the inside to the outside, this is going to be permitted because we're going from a higher security to a lower security level. However, coming from the outside to the inside is not permitted because you're moving from a less secure zone to a more secure zone. So in order to permit that, we'll typically come over here and configure network address translation as well as an access control list. And that access control list is going to say folks from the internet are allowed to access particular servers inside of the organization. So each interface has to have a security level ranges from 0 to 100. The security level designates the trustworthiness. So 100 being entirely trusted, 0 being not at all. DMZ, you see it there in the middle with the score of 50. This means that we can go from the inside to the DMZ. The DMZ can get to the internet, maybe wants to do software updates, DNS lookup, send email, things like that. But at this point, no one is allowed in. In order to come in, you'll have to configure an access control list, and if you're doing network address translation, we'll NAT those private addresses being used on the DMZ and being used inside to public IP addresses on the outside. So default security policy, outbound traffic is allowed and it's inspected by default. So we know what allowed means. What does it mean if something's going to be inspected? Well, you can actually see this. If you do a show run, you'll see all of the protocols that are going to be inspected out of the box. Things like FTP, SIP, H323 perhaps. It's going to vary a little bit based on your version of code. But if you do a show run, or you just go ahead and check it out from your GUI, you're going to see certain protocols that are being inspected. Now, when we talk about inspection, it says, hey, firewall, pay attention to these applications because they need special handling. We'll get into the types of protocols and the special handling they require later, but there's certain protocols that are inspected by default. So for example, if you want to use FTP, which uses 2 different channels, one for command and control, one for data, so 2 different TCP flows. If you want to do that through a firewall, you have to inspect FTP. A lot of people don't know it, but TFTP does something very similar. In order for TFTP to work through a firewall, we need to inspect TFTP. These inspections are happening by default, so it just works automatically, as some people say. Realistically, your firewall is sitting there under the hood, inspecting all those protocols, figuring out what's valid, what's not valid, and only permitting what should be allowed to go through the firewall. Again, inbound traffic, that's anything coming from a low security level to a high security level, that's going to be denied by default. If we want to permit it, we would go ahead and create an access control list. So the use case for security levels, again, here's a scenario where we've got inside, outside, and DMZ. You'll notice the outside has a security level of 0. The DMZ has a security level of 50. The inside has a security level of 100. I've probably seen firewalls configured like this maybe a couple hundred times. You could create 0, 1, 100, and it would have the exact same effect. The nice thing about spacing them out is it gives us a little bit of wiggle room once we start segmenting our network further and further. Perhaps we want to separate accountants from developers, and we want to separate sales from accounting. So what we could do is we could apply different security levels to different departments if necessary. Remember that these interfaces can be both physical as well as virtual. So we can create sub-interfaces on a trunk link, and each of those sub-interfaces would simply be assigned a name and a security level if it was going to be able to pass traffic. All right, so this is where it gets a little bit more complicated. So if this seemed a little bit slow or a little bit too easy, hopefully this will be where I'm able to provide some value to you. Here's a scenario where we've got two different networks. They're showing a DMZ network and a partner network. But with my customers in the past, what's typically happened is someone has outgrown their DMZ. Maybe they used a native, just like a /24 mask. They've got over 250 hosts, or even close to it, and they're wondering, what are we going to do next with our DMZ? So we'll allocate a second subnet. Let's say it's 10.150.0/24 for the first DMZ. I'll create a second DMZ with just a .51/24. When I create that second DMZ, we look at it and we go, okay, are these servers any more trusted than the other ones? We go, no, they're about the same. You go, well, are they any less trusted than the other ones? And we go, no, they're about the same. And that gets us into this weird problem because the firewall doesn't know what to do between security level 50 and security level 50. There's not inbound or outbound. They're the same. And by default, this same is blocked. So there's a command same security traffic permit. And where it gets weird is inter-interface and intra. If you know those terms already, you'll have no problem with this. But if you haven't thought about it in a couple years, remember inter is between. So if I want to move between these two interfaces, G02 and G01 with the same security level, I would create a configuration change that would say allow communications to occur between two devices at the same security level. That's inter-interface. Let me show you one more, and this is a little bit niche, right? Like this only exists when you have two at the same level. We've got 101 levels to pick from. Ideally, we would avoid this, but if they're equal in security level or trustworthiness, and we want them to communicate, this would be the approach. Same security traffic permit, inter-interface. Now, this other one, I think you're going to be a bit more likely to use. It's called same security traffic permit intra-interface. So remember, the intra is within, like an intranet inside of your company. In this case, what's happening is we've got traffic coming in across the internet, hitting our outside interface, and what do? We say, is this part of an existing flow? No. What do? Look at the destination IP address. We look at where it's headed, and we go, wait a minute. It's coming in the outside interface, and it's going right back out the outside interface. That's kind of weird. Sometimes they call this hairpinning, to come in and then go right back out. And by default, that's not allowed. Well, there's a good chance you're going to want to VPN into your ASA or Firepower appliance, and then come back out of it. I do this quite a bit when I'm on the road. So maybe I'm off in some other city, I'm teaching a hacking class, I'm showing my class how to hijack traffic, and I go, I don't want them to hijack my traffic. So I'll come over here, let me just grab my pen, And it could be a scenario where I've got a laptop over here. And my laptop is building a VPN into my house. Why? I'm at DEF CON. I'm out at the hacker conference. I know lots of people are screwing with the traffic. They're inspecting it. They're trying to do man-in-the-middle attacks. I say, no way. I go, all of my traffic is going to go through a VPN. I'm authenticating the ASA using X.509 digital certificates. I know it is absolutely my firewall that I'm connected to. And based on my split tunneling policy, split tunneling's off, so 100% of my traffic goes through this tunnel. Now, when it gets to the ASA goes, wait a minute, that's not headed for internal resources. See, if you're headed to the inside, trying to get to like a SharePoint server, internal file share, something like that, you don't need to do anything special. Perhaps. I don't know what your network design is. But this is where we need something special. See, I'm trying to come in from the outside, and then I want to go back out through the outside. This kind of bends the rules of the way the ASA works. But by saying same security traffic permit intra-interface, it allows us hairpinning to occur. So what we'll build is a NAT policy that says when you see traffic sourced from the IP address pool that we assign our VPN clients, we want to change that source IP address probably to the public IP of the outside of the ASA, and then send this traffic out towards the internet. So if I'm trying to look at the news in Wall Street Journal, 100% of my traffic gets encrypted from the hotel conference or from the classroom I'm in, and it hits the outside of my firewall. Maybe that's just my ASA that's at the house, finding it through a dynamic DNS. Once I get there, that traffic is decrypted. We do a forwarding lookup. We decide that the outside interface is where we're headed. We've got same security traffic intra-interface permitted. And then we go ahead and do a NAT policy. That's going to allow our traffic to get out to the internet. There's really nice configuration examples for this, depending on the version of code that you're on. So if you're looking for it, you can do a Google search for, I think it's called VPN on a stick. Kind of like the old router on a stick analogy where we'd use a layer 2 switch and a layer 3 router upstream from it in a trunk link. It's kind of what we're doing here. So if you just look for VPN on a stick, you'll get some good configuration guides, as well as just checking Cisco's website and looking at the configuration guides for remote access VPN. They'll be able to walk you through this.